Okay, so what I've done is I found a predicted paper. So Hannah Kettle was put on a predicted paper. So there's a link there for you, so you can scan the QR code if you want to see the solutions. But I'm just going to go through all of it so you've got an idea of what might come up. Alright, so let's go through. So number one, change 20 centimetres into millimetres. I would recommend getting your ruler out for this one. You can even count them if you wanted to. But they're in 1 centimetre, there are 10 millimetres. So 20 centimetres, alright. So either you can go this way and you can times it by 10, you should get 200 millimetres. Alright. Next one, write them in order of size, start with the smallest number. Alright, so this is actually quite tricky for question 2, but that's fine. Let's put them all as decimals, because we've already got 2 of them as decimals. We've got a fraction and we've got a percentage. So that as a decimal is 0.2 or 0.20 might be more useful. And a quarter is 0.25, alright? And then you just need to look one at a time. So put a little 0 on the end of 0.3, alright, because that's more helpful. So starting with 0.2, in fact, let's keep it how they've written it. So we've got 20% first, cross that off, okay? And then we've got 0.23 next, cross that off. And then we've got a quarter next, so 0.25, and then 0.3. Right, and cross them all off. What's going on with my audio? Outside. Okay, and that's finished. Alright, moving on. So 30 plus 5 times 2, so it's bid mass. Do the 5 times 2 first. Okay, so that makes 10. So it's 30 plus 10, which is 40. Should be straightforward. 1 decimal place, so it's going to either be 5.2 or 5.3. So this is 5.28. Alright, so this is going to boost it up to 3, so it's going to be 5.3. Write down the value of the 5 in 7852. You want to look at the units, that's the tens column. But don't just write tens. You have to either say 5 tens or you can just write 50. Right, that's a lot easier in my opinion. Right, so this is the 50 part of the number. Here's a list of numbers. From the list, write down a factor of 20. So the factors of 20, you've got 1, 20, 2, 10, 4, 5. 5's on there, so that'll do lovely. Okay, a prime number. Well, to be fair, it doesn't say you can't use the same number twice. 5 is a prime number. So is 29 to be fair, but 5's a bit easier. And a cube number, that means, for example, 2 cubed, which is 2 times 2 times 2 is 8. So 8 is a cube number, alright? So in this case, what about 3 cubed? That's 3 times 3 times 3, which is 27. Is that on there? Yes, it is, 27. Okay, lovely stuff. Name this quadrilateral. Now, I'm not going to lie, you just need to learn these. But notice all these arrows, that means parallel, so it's probably going to be, in fact it is, a parallelogram. Right, but I'd rather you at least just guess the shape if you're not 100% sure. Right, on the name of this 3D shape, it's like a football kind of shape, a ball, but we have to call it the fancy name, which is a sphere. Again, spelling's not that big a deal, it just needs to be close enough to the word, alright? Moving on, bit of algebra. 2a times 7b, well, 2 times 7 is 14, a times b is ab, so 14ab, alright. Simplifying this, so let's put all the x's together first. Okay, so we've got 4x plus 3x minus x, alright. Notice the signs that are attached to them, alright, notice that. So we've got 4 plus 3 is 7, minus 1 is 6x. That's 1 mark for just having 6x. Okay, and then we need to have a look at the y's. We've got minus 2y minus 8y. And minus 2y minus 8y. minus 2 minus 8 more, goes even further negative, minus 10y. So 6x minus 10y. Alright, 1 mark for each of those. Okay, simplifying this, a lot of you will be tempted to put p6. Please don't do that. Alright, we've got 1p squared plus another p squared, plus another p squared. How many p squareds have we got? 1, 2, 3 p squares. Right, you're adding them. Powers aren't changing. It's just like having p plus p plus p, which would be 3p, but instead you've got squares. So it's just 3p squareds. 3 of them, yeah? It's as simple as that. Just gonna rub that out, I don't want to confuse anyone. Moving on. Pictogram. These are normally worth 3 or 4. They're normally fairly standard. Alright, pictogram shows some information. Sold in the shop on Monday and Tuesday. 2/7 of these bikes were sold on Thursday. Use this information to complete the pictogram. So we have got, first of all, so a circle represents 8 bikes. So this is 8. Alright, so this must be 3/4 of 8, which is 6. Alright, so every little chunk is worth 2, 2, 4, 6, 8. Okay, so we've got Tuesday, we've got an 8 and a 4. Alright, so let's put all the information on. Alright, so we've got 8 plus 6, that's 14. 8 plus 4 is 12. It says actually that over the 4 days the shop sold 56 bikes. Alright, 2/7 of this 56 were on Thursday. Okay, so 2/7 were sold on Thursday. So we need to find 2/7 of 56. Now 1/7 of 56, I know my 7 times table is, well, let's think, 8. So 2/7, 2 lots of that's going to be 16. So 16 on Thursday, so that's 2 circles. Okay, that's Thursday, and that's 16. And it's total 56, so we have to do a subtraction to find that missing piece. But first, let's add them up. Okay, so that's 10, 12, 1, 2, 3, 42. Alright, so 56 minus 42, 14. So I was basically copying the Monday one over to the Wednesday. Okay, and that's finished. Sorry, my drawing is not the best. But that's done now. They all add up to 56. You didn't need to write the equals on the number. I've just done that to keep track. Just an FYI. Ordinary fair dice is thrown. So you've got a dice being thrown 1 time. Probability, the probability lands on a multiple of 2. So your options on your dice are 1, 2, 3, 4, 5, 6. Multiple of 2 just means the 2 times table. So any numbers in the 2s, so that's in the 2s and the 2s, 4 and 6. So it's 3 out of 6. And that's a half of them. Half the numbers will land you on a multiple of 2. So pop it in the middle. Alright, we'll move on. Okay, ACD is a straight line. Work out the size of angle ABC. 3 marks. Alright, looks scarier than it is. Okay, so first things first that you need to notice is these little dashes. That means an isosceles. That means that this length and this length are the same. Alright, and it also means that the angles, this angle and the 23 down there, are also the same. So this is 23 degrees. Alright, now if we look, if I just use my highlighter to go over this triangle here, right, we can find, we're looking for ABC, but you notice I haven't even thought about that yet. I'm just seeing what can I actually find out to start with. So I'm thinking we're going to probably need to find this angle and then probably this one. Alright, we've got even more than that. So we've got to find this one. And then we've got to find this, we've got this one, and then we can find this one. What an absolute whopper this is. Okay, it's only worth 3 as well. I feel like we're going to have a scam there. But anyway, so take those 2 away from 180. So that's 23 times 2 is 46. So 180 minus 46. 134. Now I know how many degrees are on a straight line. It's 180. So I need to do 180 minus 134. So this is 46. Okay, that's 46. And then we've got another, we're looking for ABC. ABC. Now that angle, if I use my halogen, A to B to C, is this curve here. And we've got another triangle here, alright? So we've got the 64 and the 46. Let's add them up first. I think it's 110, but let's just make sure. Yeah, 110. Okay, and then we need to do 180, subtract that 110 to find that missing angle, which will give you 70 degrees. Alright, so the answer is 70 degrees. Okay, actually, I'm a little bit surprised. Sometimes these could be worth more, but what it would ask you is for showing reasoning throughout your steps. But in this case, no need. Moving on. The coordinates of A should go along the corridor, then up or downstairs, so -1 and -3. Okay, mark with a cross the point 2, 0, so 2 along and 0 up is here, that's B. And then draw the equation of the line x equals 3. Now your x equals lines are vertical, okay? So for example, x equals 4 is here, x equals -3 is here, but we want x equals 3. So I'm going to draw a horizontal line down there. I meant vertical, sorry, vertical line down there. Okay, that's the line x equals 3, and we're done. Okay, rectangle has an area of 10. Okay, find the perimeter. That's tricky. I'll be honest, these are actually fairly hard for a question 13 in my opinion. It's because it's non-calculator as well. Area of a rectangle, so that is base times height. Right, so this length times this length has to make 10. Alright, so 2 and 2/3, I don't like mixed numbers at all, so I'm going to turn that into an improper to start with. So over 3, so 2 times 3 is 6, what's left is 8 over 3. Okay, so 8 over 3 times something, we'll call it x, you know what it is, equals 10. Alright, so I'm going to have to do a division instead. We're going to have to divide instead to get x on its own, so 10 divided by 8 over 3, so that's 10 over 1. Right. The method we use for division is we keep that first fraction the same, we change that to a times sign, and we flip the fraction at the end upside down. So it's 10 times 3 is 30 over the bottom one, which is 8, so it's 30 over 8. Alright, that's x. Now this is why I think this is tricky, because it's a bit harsh really. So perimeter, you need to add up all the sides to find the perimeter, which is what it actually wants. So we're going to have to add these two together, yeah, and then add these two together. The reason I think that's a bit harsh is because we've also got different denominators for our fractions, but we move, we'll go again. Okay, so we've got 2 lots of the x's, so that would be 60 over 8, I just doubled it, so we've got 60 over 8, plus 2 lots of the heights, so doubling that, 16 over 3. Right, this is really harsh. I think this is unnecessarily difficult for an early question. Unless I'm just overcomplicating it massively. Sorry if I am. Great, and then we'll need to add them together. So we need to have a common denominator. In this case, it's probably going to likely be, well, it's going to be 24, so it's not ideal, I'll be honest. Okay, so we're times that top fraction by 3. So 6 times 18, so 180 over 24, plus we're timesing this one by 8, so 16 times 8. I'm going to have to do this myself. 128. Alright. And then add the two top numbers together. And it doesn't say to simplify it, so in fact, I'm definitely not going to. Why would we bother? 308 over 24. Right, what an absolute whopper that was. But it was worth 4 to be fair, so we put a bit of a shift in there. I would actually say, I know these are obviously predicted papers, I would be shocked if a question that challenging came up as question 13. I think that's more likely going to be a 20 plus, alright? So don't panic if you're like, oh my god, that was a bit hard. A store sells tea, coffee and hot chocolate in the ratio 3 to 5 to 4. What fraction, so look for a fraction, of the drinks were coffee? So the coffee amount is the middle number, so that's 5 over. And then we need to add them all up to get the total. So 5 plus 3 is 8, plus 4 is 12, 5 over 12. Great. Next one says write 12 to 42 in the form 1 to n. So essentially, we need to find a way of turning the left number into a 1. I would suggest we just half it and see what happens. Or actually, I maybe divide by 6, but let's half it first. So we've got 6 to 21. Those are both in the 3 times table. So then we get 2 to 7. But I want this to be a 1, so I'm going to have to half it. See how I now have a 1 there? And then I just need to use 7 divided by 2. You can actually just leave it as 7 over 2. Or you could say it's at 3.5. So you're either saying 1 to 3.5. Or if you're a little bit less confident with it, just put 1 to 7 divided by 2. Either's fine. Alright, you just need to pick one. Great. Moving on. Ben wants to buy 41 hats. Each hat costs £5.90. Estimate the total amount of money Ben will need to buy all the hats. Key word, really key, estimate. Okay. We need to round everything. Alright, now we need to round the amount of hats. So we've got 41, that's going to become 40. We're going to round to the nearest 10 because that's the numbers in the tens. And then we've got £5.90. Right, that's in the ones column, the first one. So that's going to go to £6. Alright, so all we have to do, total amount of money he'll need to buy the hat, so 40 times 6. 4 times 6 is 24, so £240. Alright, 240. That's it. If you see the word estimate, it means, oh, thank God for that, that should be fairly easy. If you don't estimate it, the question becomes harder, you spend ages on it, and then you're wasting time, and you don't get the marks. Okay, moving on. Cost of a hat increases by 20% using the exact value. So now we're not estimating anymore. Calculate the cost of a single hat. So we know a hat. So a hat costs £5.90. We need to increase that by 20%. Alright, this is a bit tricky. So let's find 10% to begin with. So that's dividing it by 10. So that'd be 0.59. Alright, just to move that decimal point to the left. 20% would be double that, so I'm going to have to double that, 0.59 times by 2. So 1.18, alright. And we need to increase our cost by 1.18, so it's gone up by £1.18. So my final step will just be to add it, £5.90 plus 1.18, add it on, £7.08. Alright, that's it. Moving on. We have a sequence. Okay, arithmetic means it goes up by the same amount. So it's going up by 7. You can always check all the numbers just to make sure. So the first bit is it's going to be 7n. That's what that tells us. And then we're doing the leftovers. So if we had 7 times 1, how many does it take to get back to 1 here? So 7 take away 6 is 1, so it's going to be subtract 6. Right, again, you do the same thing here. 7 to 8 times 2 is 14. 14 take away 6 is 8. 7 times 3 is 21. Take away 6 is 15, etc. Basically, you're working with the 7 times table and working your way backwards and seeing how many you need to take away to get that number that you had in your sequence. Then it says find the 12th term of this sequence. Well, n is the number we use to represent each term. So 7 times 12 take away 6. 7 12s are 84. Take away 6 is 78. Alright, so you're just substituting 12 in. Moving on. 180 students were asked if they prefer running or cycling. The students were in year 10 or year 11, so I'm just going to highlight key info 180. Ratio of year 10 to year 11 was 4 to 5. 55% preferred cycling, 4/5 preferred running. This has got to be worth a lot, I was going to say, because it's actually quite difficult. We'll do it one step at a time. So there's a frequency tree. First thing, we know how many students there were in total. It's 180. So that could be your first little point that goes in, first number. Okay, now we need to use some of the information. Depends which one you want to do. We could do the ratio first. We've got year 10 and we've got year 11. When you see ratio, draw some boxes. So year 10 is 4 boxes worth. Year 11 is 5. So those 180 students is shared between all of those boxes equally. Alright, so it's 180, we need to divide it by the number of boxes, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we need to do 180 divided by 9, alright, which is 20. So I can go on all these. Okay, so 20 times 4 is 80 and times 5 is 100, so now it's been split up. So there are 80 year 10s and there are 100 year 11s. Alright, so that's great, we've sorted that. It then says 55% of the students preferred cycling. Right, that's of the students, so that's of everybody. Okay, so we need to find 55% of 180, so we've got 180. And, well, 55% would be hard to do in one go, but we could find 50% by halving it, that would be 90. We could find 5% because we could divide that 50% by 10, because 50 divided by 10 is 5. So that would be 9. So that means 55% equals 99. Okay, so 99, this is the preferred cycling, but that is year 10 and year 11, so we can't really use that yet, but that is really helpful to know. Right. And then we've got 4/5 of the year 10 students prefer running. Now we know there are 80 year 10 students, so 1/5 of 80, dividing it by 5, so I have to get our bus stop out, is 16. We want 4/5 preferred running, although you could just say that means, anyway, yeah, no, it's fine. So 4/5 times in that of 80, times in that by 4 is 64. You could obviously write a multiplication out. Okay, so 64 preferred running, which means that 16 preferred cycling. Right, now if you remember, we've got this 99 people that prefer cycling. Now 16 of them come from the year 10s, so the rest must be from the year 11s. Alright, so we've got 99 subtract 16, which is 83, must go in here. Alright, so that's the cycling. And then the last step, well, that means this must be 17. Alright, that is tricky. Alright, that is tricky, but doable when you break it down. All you need to be able to do there is ratio, percentages and fractions. If you can do all those things, you're fine. Alright. One of the year 10 students is chosen at random, so we're only looking at the year 10 students. Write down the probability they prefer cycling. So just looking at the year 10 student section, so I'm only interested in this section. So it's going to be out of 80, because we're only interested in the year 10s. And we want the amount that preferred cycling, that will be 16 out of 80. Does not say simplify it, so don't. Okay, doesn't say, so don't waste your time. You might lose a mark if you mess it up. Okay, next one, we're going to be doing a multiplication. Now, these are worth 3, and actually 2 marks come from just multiplying the numbers and not worrying about the decimals. So we're going to do that to start with. So 718, you always get loads of space for this as well, times 3, 6. 6 8 48, 6 times 1 is 6, plus 4 is 10. 6 times 7 is 42, so 43. Okay, moving on to our next column, put a 0 in. 3 8s are 24. 3 times 1 is 3, plus 2 is 5. 3 7s are 21. Add it all up. Okay, and this is where I want you to use your brains. Think logically, right? This number is basically 7, right? This number is like 3 or 4, however you want to look at it. Right, say it's 4, fine. That's 28. My answer needs to be close-ish to 28. So to put my decimal point in, let's think logically in this really long number. I'm not going to put it here because that's 2,584. I'm not going to put it here, that's still too big. I'm not going to put it at 2.5, that's too small. So realistically speaking, my decimal point is going to go here, in the 25 point. Right, that's all you need to do. Alright, just think logically for that final mark. And to be honest, if you mess it up, you still got 2 marks anyway. Alright, moving on. Okay, the way I'm going to suggest we tackle this is a bit of long division. You could bus stop it. The reason I don't think I'm going to is because I think it could get quite messy quite quickly. So 1512 divided by 18. We're just going to divide the integers for now. Okay, now the way you could do this with long division is firstly, it's a subtraction method. You work your way to 0, right? So I'm going to start by doing 20 lots of 18 subtracted. Now I know, so 18 times 10 is 180. 18 times 20 is 360. I'm using that to help me. So I'm going to subtract the 360. So that becomes a 2. 6 is 5, 1, 1. Okay, I'm going to do another 20 lots. So another 360 subtracted. Okay, I'm going to do another 20 lots. I'm going to keep doing 20s until I can't do any more. One more. Okay, I get to the number 72. Now I can't do 10 more 18s, I can't do 20 more 18s to get this number to 0, because that's what I'm trying to do. Alright, but I could just do 18, for example. I could do 1 lot or 2 lots maybe, because that's 36. Let's do that. So that's 36. Right, and then I've got another 36, and that will give me 0. So then I just need to add up all these to get my answer. So 20, 40, 60, 80, 82, 84. But it's not 84, it's 8.4, because the numbers we were using were actually decimals. That's horrible, I'll be honest. That's not a nice question at all. Moving on. 153 is a product of its prime factors. Okay, so let's do some prime factor stuff. Bit of a tricky number to start with because it's not in the 2s. Normally I go for the 2s, but I reckon it must be in the 3s. So let's just check what it is in the 3s. It's divided by 3. 51. So yeah, 3 and 51. So circle the 3. Cool. Again, this is a really awkward number to work with because there's not a lot we can do with 51 in terms of times tables that it's in. I think could be potentially in the 3s again. So let's try the 3s. It's not in the 2s or the 5s. So this is one of those, maybe 2 to 7. 3 and 17. 3 is prime. Actually, so is 17. An awkward one because it's quite big, but there's no other factors. So that's 3 times 3 times 17. Key info though, it does say give your answer in index form. So that is 3 squared times 17. Right. Then we've got to find the lowest common multiple. Alright, so we're going to do a factor tree of 102 as well, and then combine the pieces together. Okay, so 102, that's, you can half that, 2 and 51. We just did 51, so that goes to 3 and 17. So that's 2 times 3 times 17, and we know that 153 is 3 times 3 times 17. Okay, now the suggestion with lowest common multiple is to put them in a Venn diagram and then multiply out all the numbers they share. So if I just put them in a Venn diagram quickly. Okay, so the ones they have in common can go in the middle. So they both have a 3 in common, so that can go in the middle. Right, let's cross off from there. This is the 102 side, this is the 153 side. They also both have a 17. Okay, and then this side, so we can cross that off. This side has a 2 and this side has a 3. So we're going to do 2 times 17 times 3 times 3. So basically timesing all the numbers in the Venn diagram. Okay, so we might have to actually get our, well, yeah, we're going to have to do this in a second. So 3 times 3 is 9, times 2 is 18. So we're doing 18 times 17. 7 8 are 56. 7 1s is 7, plus 5 is 12, 8 and 1, 306, just to check it, alright, you could actually just check, so that is times by 2, and that's times by, yeah, lovely, 306, alright, and that's finished. That is hard, I'll be so for real, that's okay, you can get some marks there. Okay, it takes 5 workers 15 days to build a house extension. How long will it take 3 workers to build the same one? So we've got 5 workers, 15 days, right? So in theory, if you have less workers, it's going to take longer. So we call this inverse proportion. So for example, if I had 1 worker, it would take 5 times the amount of time. Alright, so if I times that by 5, 15 fives, 15 times 5, is that 90? Let's just double check. No, 75. 75 days for 1, but if I've got 3, that would take a third of the time, a third of 75. Alright, so 75 divided by 3, so that's 2, remainder 1, so that's 5, so that's 25 days. Okay, so just work your way backwards. Alright. In terms of actually an assumption I've made, well, I'm assuming that they're all putting the same amount of effort in. They're all working as hard as each other. So I would say something along the lines of all the workers are working at the same rate. Because I am assuming that they're all putting an equal amount of work in. I don't know, they might not be, but that's an assumption I'm making. Okay, so we're looking for the value of y, so it says that x is double the size, but essentially in this ratio. So instead of saying x, why don't you replace that and call it 2y? Because it is 2 lots of y is x, they match. So the total number of y's, we've got 4y in total if you add them up, and we know that probabilities, they always have to add up to 1. Alright, so 1 divided by 4, it's only worth 2. 1 divided by 4 1/4 would be fine. That would be your answer, 1/4. Or you could say 0.25, but actually it doesn't say you can't leave as a fraction. Alright. Okay, standard form. So you want to take the piece, the non-zero part, put that at the beginning, times 10 to the something, have it laid out like this to begin with. Standard form, we know that this number has to be between 1 and 10, but it can't actually be 10, so we need to put a point in, and then we're going from point to point and the number of jumps. So 1, 2, 3 jumps, so that's going to go up here, but my jumps were all to the left, alright, which means it's going to be a -3, alright. The next one, so we're writing this one as an ordinary number. It's going to be a big positive one because we've got a positive power. So first thing, let's just write the number. Alright, without any decimal points in. Let's see how many jumps that is to start with. So that is 1, 2, 3 jumps. I need 4, so pop a 0 on the end. 1, 2, 3, 4. There we are, finished. That's it. That wasn't too bad. Oh, right, okay, here we are. So I just went from an easy one to a... Wow, it's alright. Right, we've got ourselves a regular hexagon. Now, how many degrees on a hexagon, I wonder? In a triangle, it's 180. In a quadrilateral, it's 360. You add 180 every time you add a side. So a pentagon is 540. And a hexagon is 720. So that has 720 degrees in it. Inside. We need to work out angle x, but I'm not even worried about that right now, I'll be honest. We're going to do something else first. It's a regular, which means all the angles are the same. So if I do 720 divided by 6, because there's 6 of them, right? 1, remainder 1, 2, 0, 120. That means all of these are 120. Notice how I haven't done all of them because we got some awkward ones in there. Alright. Now, the way they've gone about this is I see a little trapezium forming here. I don't know if you guys see that trapezium or not, but I do. You could equally just see this little isosceles forming. I know it's an isosceles because these lengths are the same. So that could be helpful, depending on how you want to do it. Alright, but first things first, I am tempted to find these two angles because they are going to be the same size. Alright, equally you've got the same one on the other side. So let's do 360. You've got to show all your work in. Sorry, let's not push forward yet. Okay, so when you say show all your work, you need to say how you find things. So angles in a hexagon, add to 720. So regular hexagon, all interior angles are equal. Basically, let's just cover all bases. So we're now going to subtract the two 120s from 360. So that's 360 minus, basically minus 240, all right, which is actually 120, okay? So in our trapezium, it's 120, which means these two angles are the same, half it. These are both 60 degrees each, okay? Which means x is going to be 60. So spoilers ahead, x is 60. Sorry about that. All right, so 120 gives you both of these. So angles, 120 divided by 2 equals 60. So angles BAD equals 60 and angles CDA equals 60. And so FAD equals 60 as 120 minus 60 equals 60. All right. So it's actually right, that one. All right. Moving on. Complete table of values. So 5 minus 2x. Let's do it one number at a time. In fact, let's do all the positive bits first. We start with 0. 5 take away 2 lots of 0. Well, that's just 5. 5 take away 2 times 0. Well, 2 times 0 is 0. 5 take away 2 times 1, so 5 take away 2, which is 3, right? 5 take away 2 times 2, 2 times 2 is 4, so 5 take away 4 is 1. And then I just want you to see the pattern. That's all you need to do now, see the pattern. Goes down 2, go down 2, so I need to go down 2, minus 1. And I'm going down 2 this way, so this is going to be 7. Alright, that's it. Not too bad. Okay, minus 1 to 7, plot it. 0 to 5, 1 to 3. It should make a straight line. If it doesn't, you messed up. 2 to 1, 3 to minus 1. Right, join up. Lovely stuff. Give the equation of any line that's parallel. Basically, you need to have the same gradients, because parallel be like this or something, you know. So I'm just going to say y equals, I don't know, 10 minus 2x. There you go. So all I've done is I've just changed the number at the beginning. All right, change that y-intercept. Okay, nearly done. Expanding these, times these, times these. So you get 2x squared minus 5x. Factorising fully, so we've got a number and a letter to take out here. Look at the numbers first. Both of these are in the 3s, so I'm going to take a 3 out. And they both have a k, so I'm going to take, a k out as well. 3 times 5 makes 15, but I also need a k, so I'm making k squared minus 7. Alright, so if you times these back out, you would get what you started with. Alright, solving this, alright, let's expand that bracket first, like you've just been doing a moment ago. So 4y plus 8 is less than 22. So 4y, we're going to solve it now, minus 8. Solve it like a normal equation, don't worry about the symbol. 14. Okay, now dividing it by 4. You can leave it as a fraction because it is a bit awkward. 14 over 4 would be 5. Alright. Or it would actually be 3.5. X is less than 3.5, but that's fine. Okay, so 45 miles in 90 minutes. Key bit here is we want miles per hour, so we need to know what minutes is in hours. So 60 mins is 1 hour, 30 mins is half an hour, so 90 must be 1.5, 1.5 hours, right, 1.5. So 45 miles in 1.5 hours. And if you remember your triangle, however you want to do it, distance, speed and time. Alright, we've got the distance and we've got the time. We're looking for speed, so it's going to be distance divided by time. So it's 45 divided by an hour and a half, so 1.5, that's quite tricky to do. But we can do it actually, because you could also do how many 15s are in 45. Well, there's only 3 of them in it. So 45 divided by 15 would be 3, but it's only divided by 1.5, so it's going to be 30 miles per hour. 30. Right. Moving on. Okay, so we've got, hold on a minute, we have a trigonometry question in a non-calculator. That is absolutely horrible. I actually can't, but it's because it's sine 30, isn't it? Yeah, okay, fine. So we've got O, we've got H. We don't have A, so we don't need it. So it's going to be sine, the formula is going to be sine of the angle equals O over H. So it's going to be sine 30 equals 14 over X. Okay, now, I'm not being funny. Very few people will probably get this, unless you have to be grade 5. So if you're not grade 5, honestly, I'd stop listening. I'm just waffling. You need to know that sine 30 is actually equal to 0.5 or a half. If you put it in your calculator, that's what you would get, a half. So 40 over x. Now, 14 over x, sorry, if you take that's times by 14, so times by 14, x is going to be 28. But like I said, guys, I'm not being funny. There are very few of you that actually need to know that last bit of info. I wouldn't even bother. Unless you're a grade 5 and you're trying to get all those marks. Alright? Okay, so that's the end of that paper. I'm going to be completely real with you. I think that's quite a tricky predicted paper. Hopefully, the actual thing won't be quite as challenging as that. I think some of those questions are a bit difficult for a non-calculator, but it's okay. Game's a game. We've got the job done at the end of the day. Any questions, leave them in the comments and I'll try and get back to you. Other than that, thank you for watching. See you in the next one.